Hello, let's continue our Sudoku adventure with Arrow-rama by ChinStrap. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have arrows in the grid. They're attached to a circle. Digits on an arrow, sum to the value in the circle. Each of these arrows is independent. They just happen to share this circle as a sum. Same with these. Now we are allowed to repeat digits on arrows. So we could do 2, 2, 4 here. All right. I mean, we're allowed to repeat as long as we can't violate Sudoku rules. Those Sudoku rules are supreme, but it doesn't add an additional non-repeat. And we always include that because if the only sum constraint you've used is killer cages have a non-repeat that come with them. And you might think then that all sums have non-repeat, but that is not true. You get what's on the tin. All right. Anyway, we also have this thicker pink line. The digits on the thicker pink line sum to the sum of these two circles. That's a double arrow. So whatever these two sum to, that's also what these four sum to. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay. I want to start here. So there's kind of a modular argument here where this sum, and whatever this value is, are all the same, right? The sum of this, and this are all the same because that's how arrows work. And so the total sum of green plus purple plus orange is going to be 3 times some number. Now, we know that the entire row sums to 21, and 21 is divisible by 3. And so we need to use a number here that's divisible by 3 in order to preserve the ability for the row to sum to 21. They sum to 21 because 1 through 6 sums to 21. I don't know if I specified that. And so it's got to be a 3 or a 6. Now 6, I mean, this feels likely to be 6. So I feel like 3 would be difficult, but that's what's happening there. And then this is going to add to 5 or 6 because we need 2 different ways to add to it. And so if we're having 2 different ways to add to it, we can't do 3 or 4, which only have one way to add. 3 is 1 plus 2, 4 is 1 plus 3. You can't do 2 plus 2 in the same row. And so this ends up 5 or 6. All right. Now, we don't get as lucky up here. But we do know that these sum the same as these. Is that helpful? Okay, so something we know does not happen is this. This green does not end up here with this purple ending up here. Like I'm saying one of these has to end up on the line. I'm saying that because if we did this, then what is this sum? Well, we know that these sum to the same as these. And so this sum here would be even. It would be 2 times whatever the sum of this is. But we know that a column adds to 21, which is odd. And so this is not plausible, which means either green or purple is on this line, which deals with its own sum, right? It takes care of itself, meaning that the other one is taken care of by the other 3 digits on the line, whichever one they are. And that is going to have to be a 1, 2, 3. Adding to 6. So our only option is to have a 6 in one of these two. And it's going to be with something other than a 6 that's then transplanted here as well, or one of these. One of these is purple or green. Hopefully that makes sense. So, but I don't know what that other digit's going to be. This could be the 6, which would allow this to be pretty much, well, not anything, but 3 or higher, I think. I'd have to think about 3, but no, 3 doesn't work. Actually, we do need 2 ways to add to this because of this here. So imagine this was a 3. Then this would have to be a 1, 2 pair, but then this would also have to be a 1, 2 pair, and we'd end up with too many 1, 2s in the column. These 2 arrows they have the same sum, so they have to have 4 distinct digits because they're not going to have 3 distinct digits. They'd be different sums if they were 3 distinct digits. And if they were 2 distinct digits, we have too many in this column. So actually, this does have to be 5 or 6. That makes this a 5, 6 pair. And that means the 5 is transplanted onto here with a 1, 2, 3, leaving behind a 4, 6 pair. But we know we're not putting a 6 on an arrow. So this is 4, this is 6, making that 5, that's 6. That's not 5. And it's exactly what I said. All right, and that's a 3, which is also exactly what I said probably happens. 4 plus 2 is 6, also 1 plus 5. Adding to 6 here, let's give me a second here. So this is going to be 1, 3, 5. That's not a 5. And this is going to be 2, 4, 6. That's not a 6. Now, this could be 2 plus 4. Well, we're not doing 3 plus 3, so it is 2 plus 4. Which means this can't be 2 or 4. Well, these can't be 2 or 4. Because this is known to be a 2, 4 pair. It's not 2, 2, it's not 4, 4. And so they are, one of them is 2, one of them is 4. And so these see the entire pair. So this has to be the 6. And these can't be 2 or 4. These are from 1, 3, 5, 6. All right. Just to bake that in. All right, we just got a lot. 6 is one of these two. 2, 4. Okay, adding to 5. I'm certainly not putting a 6 here or a 5 here. So we're going to be either 1 plus 4 or 3 plus 2. And then this is the other one. But we have a 2, 4 pair here. So this has to be also the 1 or 3 with the 2, 4 here, making a 2, 4 pair here as well. So yeah, this 2, 4 pair, this 1, 3 pair, that tells us that is 2 different ways to add to 5. This has the other 1, 3 that isn't this one with 2, 4. So it's from 1, 2, 3, 4, right? Doesn't really help, does it? What else do we have? What are these 2, 4s? Should I color them? I don't know if I need to color them. I want to color them. Oh, wait, let's just do this. This 2 looks up. That puts a 2 in one of these two. That's going to point, telling us this is the 4, this is the 2, this is the 2, this is the 4, and that's the 4. All right. That cannot be 4, meaning that can't be 1. This is from 1, 3, 4. So the 4 can only go here in the row. And this can't be 3. So that's 1, that's 3, that's 1. Oh, we could have finished the sums as well. That's 5 and 1. That's a 6. That places the 6 here. This is a 5, 6 pair. We know the order. That's 5, that's 6. This is a 3. These can't be 3, and that means this isn't a 2, which places the 2 here and 5. All right. 1, 3 pairs left. Oh, 1, 3. That's the 5. This is only 2. That's 2, that's 4. This is also a 1, 3. Oh, also a 1, 3 pair. This is a 2. And wait, what's going to resolve these 1, 3s? This is a 5. Oh, it's this 4. 1, 3, 1, 3, 1, 3. All right, cool puzzle, ChinStrap. I enjoyed it. That was a neat idea. I liked this a lot. The fact that, I mean, I probably would have streamlined things by figuring out that this was a 5, 6 pair first, but I liked doing the math on this and also the outie here. There's another way to find this outie, which is a bit more straightforward, which is that this had to be 5 or 6. If it was 5, we'd be omitting the 6. If it was 6, we'd be omitting the 3. But anyway, it's more fun to do the sum thing. I think that's a nice tool to have. And it led us into this one as well for even versus odd. All right. Well, how'd you do?